Hi, everybody, and welcome to the second day of the general track of SciPy 2021. Thanks for joining us. I just wanted to remind everyone that if you have a question during the talk, then there are, over on the right-hand side of your screen is the chat, but you can notice up at the top there's a Q&A tab where you can type in your questions or you can raise your hand, and I'll call you up on stage to ask your question when the talk is done. That's all I have to say. Please join me in welcoming David.
Hey, thanks. Hey, everyone. Welcome to my talk on how to defeat obscure file formats with Parsita. Now, Parsita is a parser combinator library for Python. That means that it is a library for quickly and easily writing text parsers in Python. I'm the lead maintainer of Parsita, and I'm here to tell you a little bit about what it is for, a little bit about how it works, and quite a bit about how to use it, all framed in what is hopefully a little bit of a fun scenario. So if you've worked in scientific programming for a modest amount of time, you've likely encountered an obscure file format. You know what they are. They aren't JSON, they aren't XML. If you're lucky, they're ASCII instead of binary. They are the output of some scientific instrument or scientific program. Maybe it's proprietary, or maybe it's just the print statements of the last grad student. But there's no spec, and there's definitely no parser. Perhaps the output was never intended to be consumed by a computer at all. The author was simply expecting you to copy it all by hand into your physical lab notebook like it's 1972. Yeah, no, you are going to slurp it into Python and do your analysis there because, well, slurping your data into Python and doing your analysis there is kind of what this conference is all about. So if you encounter a weird file format and you want to read that file into Python, then first look for a parser for that format on PyPI. The first rule of Parsita is don't use Parsita. As much as I love using Parsita to write parsers, I still use someone else's parser whenever I can. But if there's no parser available, or that parser that is on PyPI is not good enough for your needs, then you're going to have to write your own. And you pretty much have three main tracks for writing your own parser. First, you could write one from scratch using loops and regexes. I've done this before. It's very painful, and I do not wish it on anyone. So do as I say and not as I do, and all that. Though I guess I use Parsita now, so do as I do now and not as I used to do, I guess. A more proper way to do it is with a parser generator. With a parser generator, you have a separate file where you write the grammar in some domain-specific language, and then you run the parser generator program on the grammar file, and that generates Python code that you can use as a parser. It's a pretty common method. It's an older method. I'm not really a huge fan, mainly because of the separate build step, but also because getting a particular Python object out at the end is usually, but not always, kind of painful, because the grammar file, which is not Python, doesn't typically make it easy to run the Python code necessary to assemble arbitrary Python objects that you might want out at the end of parsing. You usually just get a parse tree, and then you have to finish parsing the tree manually into your data class or whatever you want out at the end. And the third way is to use a parser combinator library. A parser combinator library lets you write a parser directly in code, in this case, Python code. And good parser combinator libraries take full advantage of the language to try to make the parser code look as much like a proper grammar as possible. For example, Parsita, one such parser combinator library. You shouldn't understand anything that's on this slide yet. I just popped this up as an example of a Parsita parser to give you a vague hint about how pure Python code might be able to look like a grammar. So you can see there's literal strings and some regexes and operators combining the whole thing together. You know, a value is a number or a false or a true or a null string array or object, for example. And yes, these are real Python operators. Like all good parser combinator libraries, Parsita implements operator overloading to provide its clean grammar-like syntax. The or dunder method is defined to provide alternatives. A number is an integer or a decimal. The and dunder method is defined to provide sequences. A greeting is a hello, followed by a comma, followed by world. And there's some other operators that we'll talk about later. Now, in a technique that I think is unique to Parsita, Parsita uses meta-class magic to allow forward declarations in grammars. This means that you can use a variable before you declare that variable in Parsita. Now, you don't have to use this feature, but it does make for some very clean declarations of recursive grammars, which in practice are actually pretty common. Anyway, let's stop talking about Parsita in the abstract. Let's see it in action. And the real action of Parsita is in the writing. Let's write a parser for an obscure file format. Now, I didn't want to throw any particular scientific tool under the bus in this public talk, so I won't be using a real obscure file format, but instead I will be using the invented file format that you see here. If you must have some context, then let's say it's from a parallel universe where Guido van Rossum left retirement not to join Microsoft, but to join a startup making IoT blockchain-enabled home-baked pizza ovens called MyPy. This .py file is the log file format from one of these pizza ovens, which I purchased before it went belly up. I want to parse the log file as part of my effort to reprogram the internal Raspberry Pi to cook, well, Raspberry Pi instead of pizza. Let's get to parsing. All right, so what we have here, a blank IPython notebook on the left side and the .py file on the right side. And so the first step of parsing any obscure file format is to inspect the file format to look for the data that we want to extract in the sea of the keywords and delimiters. So in this case, we see that there's, looks like some kind of start time for the log. And this is obviously a cook time because it's labeled with some keyword. And then there's an ingredients list, which looks like some kind of recursive data structure, like a dictionary that can have dictionaries inside of it. So when I'm parsing something, I like to first write out the class for what I'm going to be parsing into. What is the object that I want out at the end? In this case, I'm going to make it a data class. Might as well make it frozen, because why not? And a class, let's just call this a pizza log. And there are three elements. There's a start time, which is a, let's make it a date time. A cook time, which I guess is going to be a time delta. I'll import these later. And finally, the ingredients, which is going to be a dict string to, it's recursive. I don't feel like actually having a proper type, so I'm just going to put any. All right, let's import what I need from datetime, import datetime and time delta from data classes, import data class, and from typing, import any. All right, and that should be, I should have imported everything correctly. All right, so that's the data structure that we want out at the end after parsing this. So I'm going to import from Parsita everything, import star. You don't have to do it as import star, but for the sake of this demo, I'm just going to import everything to just save time. All right, the first step when writing a Parsita parser is to declare a class that inherits from text parsers, if you're parsing text anyway. If you're not parsing text, that's kind of a totally different demo. Now, the text parsers and subclasses of it are not intended to be instantiated. You don't get instances of text parsers. This is purely used as a context in which the parsers can be written. Now, this context is what handles like a common white space definition, as well as the forward declaration meta class magic. That all happens within these class bodies. You don't have to use these class bodies, but it makes it like simpler and cleaner. So we're going to use them. All right. So when defining parsers, for parser combinators anyway, the best way is inside out. So you narrow down to the smallest unit that can be parsed. So like smaller than time would be like an integer. So an integer is probably the smallest thing that can be parsed here. Parse that, and then use the parser combinator operations to combine the parsers into a larger parser. So let's define an integer as a regular expression. So there's a reg function in Parsita, which you will use a lot if you use Parsita, and it just takes a regular expression, in this case, some digits. And this is now a parser of digits. So we can run that. And let's actually use that to parse something. So this is a Parsita parser. So it has a parse method. It takes a string. Let's make it something that's parsable. And we'll run that. And it returns an instance of the Parsita result type, which has two subclasses, success, which if it succeeds, it has the value that was parsed, or a failure, which contains a message about the failure. A useful method on the result type is the or die. So parse or die is how you can read that, which if it's a success, it unwraps the value and returns it. If it's a failure, if it's a failure, say we put something in that can't be parsed as an integer, it will raise an exception. So I was expecting something that looks like an integer, but found foo. And it also gives some lines and characters and little arrows, which is useful if you're parsing something larger. All right. So the first operator we're going to learn about is, you notice that this returns a string, which is not really what we want. We want like an actual integer out of here. So the first operator we're going to learn about is the greater than or equal sign, which has been repurposed as a pipe function. And this takes a function on the right-hand side and a parser on the left-hand side. And this creates a new parser that matches the exact same thing as here. It runs this parser, but then if it succeeds, it takes the successful value, pipes it to this function, and whatever this returns is now the new success value. So now I've changed the success value to an actual integer. All right, now we got to do some parser combinating. We're going to turn this integer into an actual time. So a cook time is like a number, three numbers separated by colons. So it's going to be an integer. And then the next operator we're going to learn about is the and, which I talked about in the slides. A colon followed by another integer, followed by another colon, followed by an integer. All right, so let's actually use the cook time parse and run that. And sure enough, I've parsed it. I've matched 5 things in a row. Here are those 5 things in a list. That is what a sequence of ampersands will turn, or that's kind of parser will turn into. A related parser, a related operator, I should say, is the discard operator. And so that is right shift and left shift. What this does is it discards the token on this side and doesn't store it. You can think of this as 2 little mouths eating the token that's being discarded. There is a complementary operator for the left shift that discards things on the left. This matches the same thing, except it's now discarded those 2 colons. So now I just have 3 little numbers. All right, let's pipe this into a time delta. This is coming in as a list. So we're going to have to make a lambda that unpacks it, because this parser still only captures one object, namely this list. So that list is going to be in here. And the time delta is then going to be, what is this? Hours equals the first element. Minutes equals the second element. And seconds equals the third element. And so now instead of a list, we're going to get an actual time delta out. Yay. At this point, I think I want to introduce you to a little helper function in the utils module of Parsita called splat.
Pete, sorry, just a quick thought. Could you increase the font size on your screens?
Absolutely. What's wrong way? Here we go. And let's drag this out like that. Is that better? All right. Cool. So what splat does is it takes a function, it converts a function from a function that takes actually multiple arguments. So we do hours, comma minutes, comma seconds, which is how we would like to write this. Hours, minutes, seconds. But this won't work because it's the pipe operator is still only passing in a single argument. But if I apply splat to it, that will take that single argument and splat out the three elements into the three arguments of the interior lambda. So this gives me the exact same answer, but is a little bit cleaner. So cool. All right, let's move on to the more difficult piece. So now we got ingredients. So remember, inside, out. So here's the whole ingredients. A single entry is like a name equals a number, but it's not an integer. It's like a decimal. So this is going to be a regular expression where what's the regular expression for a decimal? It's like some integers followed optionally by a literal period followed by more numbers. And let's get this as actually a float. Let's just verify that this actually parses. And ta-da! Oh, all right, that's a float. Oh, I want to back up a little bit. I skipped the start time, which is actually more like the cook time. So let's just do that one real quick, and we'll come back to the ingredients. Start time. So what do we look at this? So it's an integer followed by slashes. So let's get an integer followed by a slash that I want to discard, followed by another integer, followed by another slash that I want to discard, followed by another integer. And then that's followed by a space. And inside text parsers, white space is discarded. So I can just say it's immediately followed by another integer. And I think actually the rest of this is the same as the cook time. So let's just copy and paste this so we can save a little bit of time. And let's verify that this parser is actually parsing the start time correctly. And sure enough, it grabbed all 6 of those numbers. We want to pass it into a date time. I think the date time has a useful signature. So I can just pass all 6 of these things in the right order. I don't need any keyword arguments. So let's use our pipe into splat. And we'll make a lambda for this, where I have to capture the argument. So they're all in this order. Let's assume this is a bad American format, year, or what is it? Yeah, month, day, year, and then hours, minutes, seconds into a date time. And we just need to put these in here as the right order. Date, seconds, hours, minutes, seconds. And that's, sure enough, I get a date time. I probably want to add 2000 to turn that into an actual date. So there, we've parsed the start time. All right, back to the ingredients. So we parsed the decimal appropriately. Now we just need to remember inside out to entries. So let's parse an entry. What does an entry look like? It is a name. Like it looks like a regular expression, probably of just lowercase letters. So A to Z plus. That will seem to work. And then an equal sign, which we don't want. It's just a delimiter followed by the decimal that we just defined. So let's parse one of these. And sure enough, all right. So there we got an entry, a name, and the thing it's pointing to. And this is not entirely correct because it's not just a number it can point to. It can then point to an ingredient itself. So we're going to learn about two Parsita features in rapid succession. The first is the OR operator. It can be a decimal or an ingredient. And here's what we're going to learn about the forward declaration. Ingredients has not been defined yet, but we can define it down here. So an ingredients is some braces, which we don't want. And then there's a list of entries inside there separated by commas. So a list of something separated by something else is the rep sep function in Parsita. So this is like a very common thing to need. And so this takes two arguments. The first is the thing we want to match. In this case, it's an entry. And then the delimiter, which will be discarded at the end. So we'll only get the list of entries out, which was what we want. And we'll throw away the last brace as well after matching it. So let's try to match an entire ingredients. This is going to require a multi-line string. And see what we get out of this. Yeah, sure enough, we got a list of length 2 lists, some of which can be internally nested. A list of length 2 lists, if we want to convert that to a dictionary, is actually just the dict function. We'll pipe that whole thing in there. And sure enough, then we get a dictionary that's probably the data type that we want at the end. So we've matched the three things that we need. Now we just got to start putting it all together. So what do we got here? We haven't matched this cook time or this ingredients yet. So we need like a cook time line, which is going to be the word literal cook time, which we don't want, followed by an equal sign, which we also don't want, followed by the actual cook time over there. And this is actually going to error. But I want to show you the error because you will get this in Parsita. Unsupported operands of type right shift for string and string. So I've glossed over the fact that this operator is defined on Parsita parsers. It accepts strings, but actually converts these strings into literal parsers, like it will literally match this. But this doesn't work if you put the operator between two strings, because Python doesn't know how to let right shift two strings. So you have to manually convert one of these to an actual Python parser, like this lit, and then this will actually run. So let's verify that this actually does the cook time, does in fact parse that. So ta-da, we got the time delta. All right, the ingredients line is basically the same thing. So I'm just going to copy what's up here and modify it a little bit to be the word ingredients equals the actual ingredients. And I won't test that because that's just going to work. All right, and then we put it all together. That's all the pieces into a pizza log, which will be, starts with a $run, which I want to discard, which is then followed by the start time, and then followed by a cook time line, which is then followed by the ingredients line. And that's followed by an end, which I want to discard. So run that, pizza log, parse. Let's grab the whole thing. I could read the file in, but I feel like copying and pasting. And sure enough, parsed that into three arguments, a start time, a time delta, and the ingredients. I still don't have my object that I want, but these three arguments are the three arguments that pizza log needs. So I'm just going to splat it directly into the constructor, rebuild and run, and voila, a pizza log, taking a start time, a cook time, and in ingredients. And we have parsed this obscure file format. Thanks everyone for joining. Installing Parsita is easy with pip. It is a pure Python library. Here are the links to the documentation and the source repo, though a web search for Parsita will land you in the right place too.
Thanks very much, David. Looks like there were some questions that were written in the chat. I'll go ahead and read those off, the ones that I saw. There was questions about higher level ways of parsing time strings, the time string example that you showed, and maybe built-in regexes for tokens like floats. Are there some higher level ways of doing some of the things that you showed?
Yeah, there's not a whole lot of higher level things. Like I'll take the float one in particular. Like the correct regex for a float is actually very much in dispute and depends very much on your application. And so I have, internally used multiple regular expressions for floating point numbers, and it depends on the situation as to what I want to accept and what I don't want to accept. I could include kind of a generic one in Parsita, but I don't, mainly because there just isn't a clear right answer.
Gotcha. And for the strings, by the way, everyone, if you'd like, remember to type some questions in the chat or raise your hand if you're interested. Yeah, were there thoughts about the time one as well?
The time one, yeah, it's like 3 things separated by colon. I mean, there isn't one. Again, that would be kind of a specific case, and I don't know, it takes 2 lines.
Yeah, right.
Yeah, basically no. The answer is no. I don't have a lot of like narrow case pieces in Parsita. If there was enough demand for them, I think I could be convinced to put them in. But individual use cases actually vary a lot more than individuals think.
Sure. Gotcha. All right. Well, I'm not seeing other questions in the chat. Thanks very much for a great talk, David. And yeah, everyone, please join me in thanking David. And I'll go ahead and end the session in a few moments here.
All right. Thank you very much.